Hello everyone, my name is Prashant and today I'm going to talk about something called a kernel modules. So in the previous topics or in my previous video we specifically talked about the kernel, CPU, IO and memory and all those things. So this is something kind of an offbeat topic, but Linux kernel is like a modular in nature. We are like I know most of you knows about that a monolithic kernel versus the microkernel, and this kernel borrow its feature like dynamic loading and unloading of modules from the microkernel. So let's look at one basic unit called a module, which is like a really important, and what exactly a module. So in the simplest of the definition, they are a small extension. So like uh, if you look at your kernel, you have like some of the modules which are already inside compiled, which are essential for the kernels are already compiled inside directly inside your kernel. So because you don't want to make your kernel like a really huge kernel, so that's why they are just simply a sets of modules which are basically inside your kernel, and whatever the modules which are required essentially at the boot time is provided by something called initrd or the initial RAM disk. So because of this kind of approach, modules can be added or removed without a reboot. Like in a case of your Linux kernel, you can add or remove a module without need to reboot your system. So what exactly a module? So a kernel module is a small kernel extension, or we can say it's a kind of an optional kernel code that can be loaded into and unloaded from an already running kernel. Okay, so the important part about the modules are they always operate in the kernel space. If you need to look at the modules, they are simply a relocatable object file which ends with .ko extension, can implement as a drivers, file system, and firewall. So in the basic sense, we can say that the modules uses a Linux kernel like a shared library, linking to it, and only through a list of symbols and functions which have been exported and thus made available to a given module. So the most important part is like a module can depend on other modules, and there's a order of loading and unloading may need to be done carefully. Like one module will depend upon the other module. So this is a presentation which I have made in which I mainly focus on the demo part rather than to show you guys like a bunch of slides. So let's see like where you can see whatever the module which is present in your system. So let's go to my second screen. So whatever the modules which is present in your system, just one second. Disable. Okay. So whatever the modules which is present in your system, or depending upon your kernel version, you can see it over here. Okay. Just go inside the kernel directory, and let's say I can go inside the drivers. Go inside any of the drivers. For example, let me go inside the network, and here you can see the bunch of a .ko file. So like I mentioned earlier, they are the relocatable object file with a .ko extension, kernel object. Okay, and as I mentioned that there are only few essential of modules which are compiled directly inside your kernel to make your kernel as small as possible, and whatever the other which is required during the boot time is supplied by something called initial RAM disk or initRD, or in the case of CentOS or 6 or RHEL6, you have something called init RAMFS image nowadays. Okay. Or if you look at your boot grub.cfg, right? Yes. So you have init RAMFS images. Okay. Whatever the modules you need, specify over here. So if the module present inside the kernel, it will be Y, or let's suppose something called -m, which is a module which you can load and compile uh, inside your kernel. Okay. So because of this modular approach, you can add and remove any modules without rebooting your system. Okay, so modules are really important. You can let's go to the demo part and I can show you with the help of another example. This is a simple module which I have downloaded. So here if you can see you are initializing a module over here, okay, and you are then doing a cleanup. So here you can see that all modules contain a callback function for initialization as well as for the cleanup. Okay, and these are called when modules is loaded and unloaded. Okay. And any modules, and this is one of the most important thing called module license. So any module which does not contain any open source license marked as a tainted one. So this is really important, that you don't want your module to be tainted. Means your modules will still going to work out, but it is always going to complain like it's a tainted. So let's say you're going to raise a case with your vendor, and the first thing they're going to check is like if your kernel is tainted or not, which you can check it over here. Process kernel tainted, and here you can see that the kernel is tainted. It is containing a non-zero value. Okay, and if you need to look more into the depth of it, I know there are a lot of ways you can check it, but I always prefer via cscope. Okay, find the text string ANTET. Okay, and we need to look at this value for tainted. So these having a different values, which you can check it over here. Okay, so not this, yes, this panic one. Yes, so these are the different values. Like for example, if a proprietary module has been loaded, you will see something called P. Module which is been forcefully loaded is specified by F. Same way, these are the different values which can state the the kernel taint state. And if you look at my previous video in which we have generated a VM core with the help of a KDUM, in the VM core you can easily see, like with the help of different flags, you can identify like what exactly been happen when your kernel was crashed or hang, whatever will happen, if it's because of the existing modules or any of the modules which you have been loaded into your kernel forcibly. Okay, forcibly, or if you added some third-party module into your kernel. Okay, so here is our simple code where we can see that we are initializing a module, we are doing a cleanup. Now, in order to compile a module, you must have a kernel source installed, or at least a part of this which are required. So let's see, lib modules, then 3.15, then bit. Okay, so we have a source installed over here, and the other thing you need is the makefile. Most of you have read it, what makefile will do, how it will help for your compiling process, and just do the make. Okay, so now it's going to compile the module for us and create the file. Okay, now I'm not sure how much of you are aware of that, but there's a command called insmod or insert mode for inserting the module. Okay, and to list out it, grep-i test. So now this module is being inserted. Okay, there are other ways you can do it. For example, I mentioned this somewhere. Yes. So let's remove that module first. To remove a module, rmmod, and mod test. Check it again. Okay. If you run this command, what it will do, it is just doing same, it is going to do the same stuff. V1 is for verbosity, and install the module in proper place so that you can so that they can be automatically been found by utilities such as depmod. Okay, we're going to discuss more about the depmod. So let's run this command. Okay, it will give you the platter of information. Don't worry about it right now. About this, the important thing you can see that it is creating a directory, copying your .ko object file over there, and updating your depmod. Okay, right now just focus on these things. Okay, now let's run the same command. I think we still need to do directly this one. Now modprobe and mod test. Now your module is loaded, so it has been automatically been picked up. So there is one more command through which you can load or unload a module called a modprobe. The important thing about the modprobe is that it will take care of all the dependencies, and you don't need to specify the entire path. Like for example, in insmod, we have to specify mod test.ko, but in a case of a modprobe, you just need to specify the name of the module. Okay, and there is one more command called modinfo if you need more information about this module. Okay, like this. So I think I already discussed about all these commands, but let's go into depth of more about it. So insmod is used to insert a module, okay, and rmmod is used to remove the module. Plus there is a command called lsmod which is going to list the module. So it basically look for this something called proc module, and it's going to give you the human readable form of this proc module. Okay, with rmmod, just make sure that the module is not being used by some other modules or called by other module. So like I mentioned earlier, modules may depend on other modules, and thus the order of loading and unloading may need to be done carefully. Okay, so if you look at this ascending module will depend on other module also. Okay, and with the help of rmmod, if you try to remove this module or try to unload this module, you will get this error. Module is in use, blah blah blah. Okay, one more thing you can do, rmmod --force to forcefully load the module, but let me show you, this is also going to fail. Okay, so the important thing is, which has been highly unrecommended, but I just want to show you that if your kernel is compiled with this option called config module force unload, then you can forcibly remove the module, but like I mentioned, it is not recommended at all. Okay, and just want to show you one thing. For example, let's look at any of this utility. They all belong to something called kmod package. Okay, all these utility, insmod, lsmod, modinfo, modprobe, remove module, all this belongs to the kmod package. Okay, earlier it is a part of something called module-init-tools, but now they all are migrated to this kmod package. I think I have CentOS installed somewhere with this one. Let's look here. Yeah, here it is the part of this package, but this is my Fedora 19 system. Okay, here it is a part of something called kmod package. So they run in, most of these utility runs in the user space with some hooks in the kernel. Okay, and one more thing, I think I have something, this script called unload.sh. Okay, so what it is going to do, it's just going to check. Yeah, for example, I'll show you lsmod, which is just going to give you the human readable output. What its script is going to do is going to check like whether whatever the modules which is running in your system is being tainted or not. So if it's come under the GPL license, for example, modinfo, any of this SND. Okay, so you will see something called license. So that's what I am grabbing it over here. So which license it is coming under, GPL, or it has been some vendor specific license. One more thing I want to show you before we move further is lib modules 3.15. Okay, you have something called modules.dev, which has been built by something called dependencies command. Okay, dependencies command. Yes, and this also belongs to the same family of package. Okay, so if you look inside this file, you can see over here like this module will depend upon this module and further this. So before loading this module, you need to load this module and this module. Okay. So dependency of the module. And let's look at some more thing. For example, let's pick any of this module. So let's pick this SND, which has a dependency for which is used by 12 other processes, and the size of this is 71725 KB. Okay, so you have something called modinfo. Sorry. Okay, and the different parameters this module support. So modinfo -p for parameter, and this one debug, slot, major, card, all these parameters supported by this module. So if you go inside this module, directory called sysmodule, which is a placeholder for all your hardware devices nowadays, or all the modules to be specific, we have something called parameters, and these are the different parameters which we have just shown with the help of this modinfo-snd command. So if the file is writable, you can just echo the value. For example, debug. Okay, the other way you can do it is with the help of modprobe command. Modprobe, name of the module, and debug is equal to 3. I'm not sure it's going to work, but it's going to work for that. Okay, the other, these are the parameters, like these are the things which can be wiped out once you reboot your system. To make those changes permanent, what you need to do inside your modprobe.d, create this configuration file, make sure it will end with .conf, and add the parameter like this, snd and debug is equal to 3. Okay, one major important thing, like I told you earlier, make sure this file end with .conf. So if you read somewhere, all the files underneath this etc modprobe.d directory which ends with .conf extension specify those options as required. So it must end with .conf extension. So that is only be needed by your modprobe if your files end with .conf extension. Okay. And this is something about parameters. If you look at something called ref_cnt, the reference count which we see here in the output of lsmod. Also you have something called folders, so same which you are seeing it over here. Okay, and there's something about modules. In case of Rails 6 or CentOS 6, you have something called blacklist, where if you don't want any of your modules to be loaded in the system, so here you can mention, you can blacklist those modules. I'm not sure why it is not present in my Fedora 19 system, or it is moved to somewhere else. So this is just a little bit introduction to modules. Modules are like important component because you can load or unload it on the fly. You don't need to reboot your system. They are basically your small kernel extension, and these are like important stuff. So this is about module. Thanks for watching this video. In case of any query and question, you can write it to me at laprashant@gmail.com. Thanks for